In this video, we will summarize the end behavior of certain polynomials. So when would the end behavior be an up-up behavior? Up-up would mean something like that, going up, up. Now let's look at all of the examples we had in our activity. So this is an up-up function, up-up function. So basically when the left side is going up, and the right side of the graph is going up. So any graph that has the left and the right side going up, that would be an up-up function. So the quadratic equation could be 1. A W shape, let me fix that. W shape, like a graph looking like a W, could be an up-up function. And in this case, if you look closer at the end behavior, so if you look at the left of the graph, it's going up. So as x tends to, let me choose a different color, a darker one. So as x tends to, or goes to negative infinity, it means look at the left side of the graph, it's pointing upward. Then f of x, or y, goes to plus infinity as well, to plus infinity. As x goes to plus infinity, it means look at the right side of the graph. Then you will see that the y, or the graph, is going to plus infinity. It's pointing upward. So since it's an up-up function, so both f of x will be plus infinity. A down-down function will be down-down. And let's look at our graphs and see when were the graphs a down-down function. We had a down-down function over here, and that's when both the left and the right side of the graph were pointing downward. Okay, and in this case, a quadratic equation could be one example, or maybe a W pointing downward, just like an M, then it's not a W anymore, and that's a down-down function. So let's look at the end behavior then. How would we write that in a fancier way? So as x tends to negative infinity, it means look at the left side of the graph. It's pointing downward. So the y, or the f of x, is going to negative infinity. And as x is going to plus infinity, it means look at the right side of the graph. It's also pointing downward. So f of x is going to negative infinity as well. So when it's a down-down function, then the f of x is negative infinity. Now down-up function, down-up function. Let's look back at the activity that we did earlier. When did we have a down-up function? Let's look, down-up function over here. So we had a down-up function when we had the left pointing downward and the right pointing upward. So it's a down-up function. So that reminds me of the cubic function, or maybe if you would like to copy one of those graphs, then any of those graphs is a down-up function. Okay? And again, if I want to write the end behavior in a fancier way, I would say that as x tends to negative infinity, so let's look at the left side. The left side of the graph is pointing downward, so y, or f of x, is going to negative infinity. And as x goes to plus infinity, so let's look at the right side of the graph, it's going upward. So f of x is pointing to plus infinity. And that's the down-up function. Now, when is your function an up-down function? Up-down. So let's look back at the activity. When did we have an up-down? Up-down. We have up-down over here. So basically when the left was pointing upward and the right was pointing downward. Okay, you see this example? That's the reflection of the cubic function. So I'm going to draw that. It's easier to draw than the other ones. So I'm going to take the reflection of the cubic function as my example. In order to write the end behavior in a fancy way, we're going to write as x goes to negative infinity. Look at the left side, it's pointing upward, so f of x points upward to plus infinity, and as x tends to plus infinity, so let's look at the right side, it's pointing downward. So f of x is pointing down to negative infinity. Okay, so what we just reviewed was a description. What is up, and what does that mean in the end behavior? But now we're going to discuss or summarize, when do the graph have this end behavior? When does the graph have an up function? When does it have a down or down up or up down? By just looking at the equation, we should be able to tell. Now let's look back at the activity and see, when did we have an up function? In order to know that, we can look at the equation. Okay, so let's look at the up function. We look back at the equation, but we're only interested in the term with the highest degree. So that's an x to the power 3. Let me just zoom in and write it down. That's an x to the power 3. Then that's an x to the power 1, and that's an x to the power 2. So what you do in order to find the term of the highest degree, you just basically add the powers. So 3 plus 1 plus 2, that's a 6. Okay? So that's the term with the highest degree. So in order to know what type of end behavior that certain equation has, you have to find the term with the highest degree, and that will tell you. So let's look closer at a couple of ones. Like this is an up function. This is the term with the highest degree. So the leading coefficient, which is basically the number in front of the x, as you can see, it's positive. And let's look at the exponent, the degree. The degree is even. So when the degree of the term of the highest degree, so when the degree is even, and when the coefficient, the leading coefficient is positive, this is when you have an up function. So we call it a leading coefficient because we're not interested in the coefficient of every single x. No, we're only interested in the leading coefficient. So basically the coefficient of the x having the highest power. So that's why it's called the leading coefficient. So when do we have an up function? When the leading coefficient is positive and when the degree is even. So if you have an even degree and a positive LC, which is leading coefficient, this is when you have an up function. Okay? Now when do you have a down function? So let's look back at the activity. Down function. There you go. Down function. So again, we look at the term with the highest degree. So basically you can look at the leading coefficient and add the powers to be able to know what the degree is. As you can see, the leading coefficient is negative and the degree is even. So when we have an even degree and a negative LC, so when the leading coefficient is negative and when the degree is even, this is when you have a down function or down end behavior. Okay? When do you have a down up end behavior? Down up. All of these. So let's look at the term with the highest degree. So positive, positive, positive. So the LC is positive and the degree is odd. So when the LC is positive and when the degree is odd, this is when you have a down up end behavior. And now remember guys, in order to be able to tell the type of end behavior, you have to look at the term with the highest power or exponent or degree. Okay? Now, when do we have an up-down function? Up-down function. So let's look at our examples. All of the coefficients are negative and the power or the degree is odd. So when the LC, which is the leading coefficient, is negative and the degree is odd, this is when you have an up-down end behavior. Okay? Now, I hope this was a good summary. Please make sure that you do the practice sheet to practice everything that we've done so far.